Go ahead, Chris.
Thank you, Vincent. And can I just do a quick mic check? Can I get a confirmation you can hear me okay?
Yeah, all good. Presentation is fine as well.
Superb. Thank you very much. Well, good morning, everybody. And thanks to the hosts, customers, and attendees today. It's also wonderful to see so many Cloudera alumni in the audience as well. Real pleasure to see you all. I'm Chris Royles. I'm a field CTO at Cloudera, and my background is very much academic. I did a number of years of research, and then I did practice as a software engineer in telecommunications, building very complex systems. And as a field CTO now, my work is really, around urgency, helping organizations move with urgency, looking for patterns and consistency, and helping make things long-lived. And that's kind of a theme that I want to cover on the session today. We've got about half an hour to go through this. On the screen, as you see, please open up chat icon. Please go into chat. Any questions that come to mind, please ask them in chat. And then during the networking event, we can go through some of those questions in some detail. Bear with me while I just adjust my screen. So I mentioned the word urgency, and if I take an example in manufacturing, we work with industries in heavy production, such as steel manufacturing. And this is a really interesting example. And when I spoke to the leader of this organization in terms of their analytics, he explained to me that they're turning some interesting dials. So they consume vast amounts of data, they store it alongside their plant, and they've started to apply machine learning to that data in order to turn certain dials. Those dials fall into a number of categories. One is putting more product through the process, driving efficiency in how that product moves through the process, but also there's always a trade-off. The balance is maintaining a level of quality. So what I thought was really interesting is by turning a dial between 5 to 6% in terms of the amount of speed of product through the process, they're now generating over 100 million tons of additional steel within that process. That's more product. That more product results in meaningful value to the business. We're talking tens of millions of dollars of return in terms of product. And the reason this is interesting is if you imagine that as a deliverable that happens in a business, and then you report on that, we're now generating tens of millions of dollars of new revenue. The question really in your mind might be, could we ever turn that off? How do we improve on that? How do we generate some growth on that? Whether it be 5 or 10%, how do we improve? And this is the interesting challenge with Severustal. So they focused on this problem because it's core to their business. That helped them generate new revenue. That helped them understand how to apply machine learning to make a meaningful impact into their business. Their focus now is on phase 2. What they realized as they drove more product is it used more energy. That generates more CO2. So they're taking the same principles of really understanding the data that they have off the plant and the turbines and generators they have on the plant, and looking to see if they can reduce the energy consumption and therefore reduce their environmental impact. And they're targeting a reduction from 2 tons of CO2 per ton of steel down to 1.8 tons of CO2 per ton of steel. It's a very small amount, but it will have a vast impact into how they, on their impact on the environment. Very small turns, but big impact on their environment. They're an energy heavy industry, so even a small adjustment can mean significant improvement. If you want to learn more about how they achieve this, at Cloudera, we do research with academic and industrial partners. And we really understood, how did Severustal go about doing this? And part of the technique that they employed was looking at time series analysis of their plant across multiple phases in the plant. And we've captured some of the best practice from that in a number of reports. So please go to our website and explore those reports. And each of those reports comes with a practical demonstration of how you could put that into practice very quickly. Use the word urgency again. How do we get to value quickly? And if we get to value, how do we then maintain that value and even grow that value? So take a look at our published research. We now make that available free and open to everybody. At this point, I want to talk about some of those small dials, let's say, that could help you and your organization think about how you apply machine learning and AI into your organization. At Cloudera, when we look at value, we define a set of benchmarks. These are benchmarks that are aggregated across hundreds, if not thousands of our customers. And we use data to drive many of the decisions we make and much of the value that we share with our customers. And these are the 4 pillars where we help our customers. And these percentages are representative of an average across our customer base. So we help them aggregate infrastructure. We help them reduce their operational costs. We help them deliver use cases faster and with urgency. And we help them increase performance in the predictions made. I think Michael might have mentioned making better predictions. And that's really a good example. Helping make better predictions, help reduce the risk. So the quality of the result can be better trusted. These are areas where we help organizations deliver value. And as I go through the presentation, keep these in mind as we talk about this. So at Cloudera, we've released our Enterprise Data Cloud. This is a public cloud native service. You can deploy this into Amazon, Azure, and it provides a set of analytical functions, such as machine learning, that you can apply to your data in your data lake on the cloud. And at the moment, we're helping our customers take their on-premise workloads, their traditional big data problems, and move those problems to the public cloud. I think somebody might have mentioned gives access to a wider range of compute resources, including GPU resources, for example, helps accelerate certain projects, but it also brings a set of qualities. And those qualities are ubiquitous access and self-service. I'll take you through some of those and make it a bit more concrete. What you're looking at here is a shared control plane across the bottom. Those services across the bottom are shared across all of our instances. And when a customer logs in, they can self-service the analytical tools that they need. So if your day job is data engineering, you go into the data engineering service. If your day job is machine learning, you go into machine learning. And likewise, if you need to manage your data at scale, into your data warehouse, all of which sitting on your cloud data lake. There's elements of this that are shared, and they're designed to drive collaboration and sharing of data across instances. So if I've got a unit in America, they can share and collaborate data with Europe. Really important thing here, though, is another aspect of the shared control plane is all of the governance and observability we put in to make sure that only the data that can be shared is shared. It's really important to recognize that. And this is what it looks like at Cloudera. This is my deployment that I use daily within Cloudera. We're a data-driven business, and we run multiple instances of our platform across the globe. We run some in Asia Pacific, some in Europe, and some in the US to provide resilience, but also to move data closer to the users of the platform and help those users self-service. So we have a number of teams in the US that self-serve against the platform. And likewise in Europe, we've just launched regional control planes. This enables a lot more privacy of data within various regions, such as Asia Pacific, Europe, and America. But the point here is what we've done is we've built a platform that aligns with qualities of paradigms like data mesh, which enables you to collaborate more effectively within your business. It enables you to step back as an IT function and enable your lines of business to self-provision the resources they need and use the tools that are most important to them close to where the data is sourced and generate data and think of data more as a product, take it through a process where it can be integrated more effectively. Data quality came up. So it's things like that that become really interesting because what you're doing is building teams that are closer to the data, closer to the problem, and understand how to work with it in a more intimate fashion. And at Cloudera, as organizations scale, we would always recommend to those organizations that you place your data scientists and analysts into your teams in the lines of business so you can understand the problem more intimately. And you can also test and validate that the solutions you're building are delivering value back into the business. Again, back to that Severustal example, they had to go after creating more product for dollar value in order to demonstrate they understood how machine learning could impact the business, but also generate dollar value for future investment. And so sometimes sequencing the machine learning use cases becomes really important. One use case helps feed into the next. This is an example of how, let's focus on AI and machine learning. This is how somebody in the line of business would provision a machine learning workspace. There's just 2 fields to fill in: name of the workspace, new research lab, and which instance you want to deploy into. Go. And that will provision a workspace in which your teams can then collaborate on building machine learning applications. Coming back to urgency, we want to help organizations accelerate their time to value. And so I spoke earlier about the research that we do between academic organizations and industry. We bring those into a report and we create a practical demonstration that you can present to your business stakeholders. One thing we've recognized is we can help you accelerate to those practical demonstrations faster and make it really concrete. So what you're looking on the screen at the moment is what we term our AMPs, Advanced Machine Learning Prototypes. These use a technique we call declarative projects. What I mean is we automate the project construction. So from a piece of static code in GitHub, version controlled, I can instantiate a full machine learning process from data ingest and data engineering and feature extraction through model training and validation and testing, through model deployment as an API endpoint. And all of that is done with a single click in Cloudera Machine Learning. So for example, on the top left-hand corner, churn modeling. And what's interesting with the churn modeling app is it shows how to do interpretability. And interpretability might be one of those things that you think about in terms of informing your customer about how decisions are made on their behalf using machine learning. It's also used in recommendations. On the right-hand side, structural time series. Again, we can materialize a practical demonstration of how Severstall improve the performance of their steel manufacturing process. And then bottom right, object detection and visualization. How to build machine learning models that can learn from images. So all of these research-driven projects are available for you to consume immediately. And like I say, to materialize this can take maybe 2 or 3 minutes. That's all it takes. And then you're in a position to demonstrate that to your stakeholders within the business. This is technical. I just want to go the next step down to make it more concrete. To do this, you just define a YAML file within your GitHub repository. So your machine learning projects are version controlled. With a single file, you can define where data is sourced from, how the model is built, how it's trained, how it's validated, and how it's deployed into a live and interactive application. And you can construct these as part of your internal assets as well. This is not just about how Cloudera presents its prototypes, but you can use this technique for your own internal prototypes as well. One of the things I like to think about going back to those 4 pillars, this is about cost avoidance. It's about making things more efficient, reducing risk because we built in automation and driving faster time to value. The other thing that we've brought in is the ability to identify and discover new data assets. And so when you go into Cloudera Machine Learning and you start a new project or you start a new session, it will present to you all of the different sources of data that you own and have permission to access. That might be constrained by geography, might be constrained by labeling, it might be constrained by the types of role that you are in as a user. But in this example, I can access my data lakes. That's the underlying store where all the data is maintained. Think of that in terms of a file store, an object store. But you can also access more curated, higher level constructs such as data warehouses. We also provide access to our streaming services and our operational database as well. And the way that we present this to the user is code snippets against the API. What those code snippets do is establish all of your authorization and authentication automatically. You don't have to worry about that as an end user. You single sign on to the platform, single sign on into Cloudera Machine Learning, single sign on into all of your data and services that you need access to. Seamless integration with your enterprise. Again, time to value. Your users don't have to worry about where they go and how they go to get the tooling they need to apply it to the data they need. This is all integrated as a singular platform. We've also been driving a number of areas of, I suppose, helping you build and operate your models at scale and into a production context. Think of that Severstall example. They can't switch it off now. So the team is really focused on maintaining it in an operational state and making sure it continues to perform as different data flows in, as seasonal trends take place, as quality thresholds change. They need to keep an eye on that model and make sure it's operating at peak performance. So we've brought in open source frameworks such as MLflow. CML is an open framework, open platform, open editor, open code approach designed on open source technology to enable you to do this. And we've embedded MLflow as a first line service under our experiments feature. Just checking our time on that. The other thing I want to touch on, I know this is an AI and ML summit, but I want to just talk about data engineering. The data scientists that I speak to, they rely heavily on the contracts they form and the collaboration they have with the data engineering teams. It's the data engineers that tend to know where the data is being sourced from and spend the time applying things like quality processes to that data and forming the data in a way where it can be exploited in terms of transformed into features for machine learning. So data engineering becomes really important. We have a data engineering service that runs Spark and Python workloads at scale. When I say at scale, I'm talking thousands of nodes for a week. I want to solve a really hard problem. I want to build a machine learning model that's used to drive a car. This is a hard problem. It requires scale, masses of resource, masses of processing. And so data engineering is really designed for that reliability and to deliver that reliability against a very, very high-end SLA. Many of our organizations in the enterprise space, such as financial services, they need to report within 4 hours. And so they need to do all of their machine learning processes or their data engineering processes within a 4-hour window. So you might want to explore our data engineering service in the context of machine learning and AI, because it can be used to build machine learning models at vast scale. The other thing is we've got operators built in using Airflow for integration with our data warehouse and integration with our machine learning API. So again, you can fully automate your data engineering pipelines, and you can fully instrument them and make them observable. I hope this animation comes through clearly on the presentation. Sometimes it doesn't, it might stall. Within Cloudera machine learning and within our data warehouse, we've embedded visual applications. Visual applications are primarily designed to bring data together from multiple sources and create a data model, and then to tell a story through visuals. But we've also integrated a number of machine learning features into here, so you can do forecasting and predictions based on the machine learning model endpoints that you deploy. We delivered it into our data warehouse, so you could do traditional business intelligence and analytics, and we delivered it into Cloudera machine learning. And the reason we put it into Cloudera machine learning is it helps you to build visual analytics and stories on top of your machine learning models. You can easier tell a story, but you can also monitor telemetry, such as model drift and model performance. And you can use this visualization to help drive that. It's embedded, it's part of the service. One of the innovations we've put in is the ability to just ask questions. So I could type what I want to find, and remember what I said earlier, we can discover data in the data lake and warehouses and automatically bring it together. Those data models can be blended and federated, and I could just search for it. Flights, trend, by year. Then I can choose the best visualization that I need to tell my story. So again, I want to get to information, and I want to get to business stakeholder story faster. And this is one mechanism we've embedded in order to achieve that. At Cloudera, we have a mission about making analytics accessible to all. And this is an approach to make it more intuitive, question-driven, and self-service to every user within your organization. I just want to be clear. Some organizations have thousands of analysts and data scientists using our platform in production today. And we're proud to have those customers on board, and we're helping them achieve acceleration in how they get to value faster. I also want to tell a few more stories. JP Morgan and Chase, their Coins platform. This is a platform we've been maintaining for a number of years. But what's interesting about this particular example is Mariana Lake, who's the lender's financial chief, she said, you can't wait. And I'll quote her, we're willing to invest to stay ahead of the curve, even if the final analysis, some of that money will go to product or a service that wasn't needed. The point there is prepare to fail, because on the journey, you might have to go through a number of scientific experiments, but make investments where you can afford to fail. That's because we cannot wait to know what the outcome, the end game, really looks like, because the environment is moving so fast. And that's the thing I reflect on whenever I talk to leaders within my domain. Things are moving so fast. How do organizations keep up? How do they produce better products and services? How do they compete more effectively? I just want to take you through a couple of calls to action. Please go onto our website. We provide a breadth of enablement. All of our courses are on demand, and we've seen a big growth in access to those courses recently, obviously with people working from home and during lockdown. Everything's available through on-demand services. If you tick the box, we've got some complementary training as well. And I'd encourage you to look at the Introduction to Cloudera Machine Learning and our Cloudera Essentials for CDP. That'll tell you about the platform and then focus you into machine learning and what it can do and achieve for you. And I think I went backwards on the slides there. Bear with me a second. The other thing I'd encourage you to do, the link is at the bottom, and I will put it in chat later, is if you go to cloudera.com/users.html, we've got a number of interactive tours. One of those tours is around Cloudera machine learning, and one is around data engineering. Please explore those at your leisure, and then go and have a look at the tutorials. These are aligned based on role. So if you're a data scientist, there's a set of tutorials for data science. If you're a data engineer, there's a set of tutorials for data engineering. And they'll take you through the best practice on how to carry out those activities. For example, data science, there's an example in there with all of the assets you need to build a machine learning model to look at the performance of turbofans, for example. And the final case study. And this ties into the commentary during the panel discussion on ethics and bias. I would suggest, in order to learn more about that, in order to apply the best practice, you need to think in terms of observability and auditing. We would not have been able to do this without, as part of the data engineering and machine learning processes, if we hadn't captured the level of observability, auditing, the lineage and governance, and if we hadn't had a formal model operations process, we wouldn't have been able to establish trust. Without trust, we would not have been able to bring this solution to market. Our clients are reporting that this system has saved hundreds of lives, over 500 lives, in the area of sepsis. This is blood poisoning. Make sure you don't release patients back to home if they have a high risk of contracting that blood poisoning. And so this is really helping hospitals make informed, data-driven decisions on who they retain in hospital in order to reduce their risk, fundamentally, of death. We're really proud at Cloudera to have helped with Cerner save hundreds of lives by bringing this to the market. At this point, I just want to say thank you. I haven't had visibility on chat. I'll go and explore that later. And I know there's a networking event coming up shortly. Lucy, we might have a few minutes for questions.
Perfect. Yes, well done. Very nice, organized. Thanks a lot for the presentation. So questions, please. So I'm just waiting. If there are questions in the chat area, please, we are waiting.
There's a couple of things I can see, but investment is also in people, and investing where AI helps. Investigating where AI helps. Absolutely. It's important to invest in people. It's also important to think in terms of where you can get help. And one of the areas at Cloudera that we do quite a lot of work in is helping organizations in understanding which sequence or which use cases to go after. We do have a team that helps with that. It's a consulting engagement. They treat themselves as your geek or your data scientist's best friend. It's really helping supplement your data science team. A lot of organizations I work with have 1 or 2 data scientists. And so by bringing in our Fast Forward Labs team, they can really help supplement that team and bring maybe different viewpoints and different perspectives to bear there. We work with a UK stats authority, and the FFL team engage with them to look at opportunity to help accelerate very manual processes, a bit like the coins example at JP Morgan and Chase. How can we take contracts, use natural language processing in order to learn from those contracts and reduce the manual task at hand? So that's certainly a very important area to explore. From a training perspective, we've just released a book at Cloudera designed for children. It's designed to help children understand retail and the types of data and analytics in retail. My daughter, she's 9 years old, and she's just been tasked at school with building a small tuck shop. And so we provided the book to the school to help the students understand, or the children understand, how to apply data, even at that level, in simple terms, what products to select to put into the tuck shop. And it's really helping them think about the bigger picture, as well as help them at a very early age understand why data could be so important in kind of real world problems. Mazin, are there any other questions from the audience at all?
Not in the chat area, which I have, unless they have directly been sending the questions to yourself. But no worries, we have possibility of chatting with you now in the breakout time. In just 2 minutes, we start with the breakout times. There they can ask you questions, or chatting after the breakout time with you again to question, or on the LinkedIn page. Yeah, thanks a lot, Chris, for